So a system means we have two or more. And we've done systems of equations, so the next step is inequalities. So basically two or more inequalities at a time. With these, to get our solution, it'll actually be a graph. Because there are many, many ordered pairs that would make it true. So we are trying to get a picture of every ordered pair that would work. So to solve these, we will graph. And I'm sorry, if I were nice, I would have printed it for you, and I kind of forgot. So you get to draw graphs today. Do you need rulers? All right. What would I need to do to graph that first one?
You have to have the exponent or something.
Yeah. It's just a line, so we want y equals mx plus b form. So if we subtract the x. So then when we graph it, we have a line. The y-intercept is 2. The slope is -1. So you could go up 1 and left 1, or down 1 and right 1. Then you have to watch if you have a solid or a dashed line. How do you know?
Inequalities
Equal to would mean solid, not equal to is dashed. So this one would have a solid line. And then we have to shade. We will either we'll be shading one side of this line. There's a couple ways to figure that out. Do you remember? Yeah. You basically could put in any point that's not on that line. 0, 0 is the easiest, but if it falls on your line, you have to pick something else. But you can put it in. You can do the original or our answer, it doesn't matter. If I put it in, I get 0 is less than or equal to the opposite of 0 plus 2, which is 2. Is 0 less than 2? Yes. So that means 0, 0 does work, so it's part of the solution. So that means anything on this side works. This is not my final answer, so just lightly shade this in right now. That's the answer for that line. So currently I know any ordered pair under that line would work. Another way of getting that, this is, if you're dealing with lines, less than is below, greater than is above. So since it was a less than, it was below the line. So just kind of a shortcut. Now we do the second one. So get the y by itself. So we graph it. Intercept of 4, slope -2. Also had an equal to, so also solid line. So, can you use my trick? Do you know which side you would shade? The top side. So this way. If you didn't, if you put in 0, 0, you get the same thing. You would have 0 is greater than or equal to 4. That is false, so that means you can't shade 0, 0, so we shade the other side. Then our answer on these is the overlap, the part that got shaded by both. And so it's this region down here. So your final answer, I need to be able to tell what that is. And people have different ways of doing that. Some people like to go back and erase any other shading. Some people just color that in really dark, some people highlight it or something, use a pen, it doesn't matter as long as I can tell that's your final answer. So that means any ordered pair in that blue region would make both of those original inequalities true. Alright. Let's try. Do you guys think you could try one? If you divide by a negative, what do you have to do? So first one, you subtract your x. You know, I yell at my kids when they pop things.
My mom knows.
Divide by -2. And dividing by a negative flips it, so we have a 1/2 x minus 3. Okay, because it is a less or greater than but not equal to, that would be a dashed line. And where do we shade? Above, because of the greater than. Or if you put in 0, 0, you would get 0 is greater than -3, and that's true. So you have to shade where the 0, 0 is. Okay, second one, if we subtract the 2x, divide by -4, which flips it, we get y is less than 1/2 x. So y-intercept is 0, slope 1/2. What's true about these lines? Parallel lines, same slope, they're never going to intersect. Also dashed. Just coincidence that both of them are dashed on this one and they were both solid on the last. It's possible to have one of each. Less than would mean below this line. Could you use 0, 0 for a test point? No, because it's on the line, but you could, if you wanted a test point, do like 0, -1. And if you get that, you'd have -1 is less than 0, which is true. So you shade below. So then our solution, the overlap is in between these parallel lines. Let's try a nonlinear. So if we look at this, I have to graph x squared plus y squared is greater than 9. Do you know what that looks like? It's okay to say no. So what do we do if we don't know what it looks like? If you don't know how to graph something, what do we always do to start? XYZ chart, okay. Let's see if we can figure it out. Let's try some easy ones. If we put in 0 for x, and we're going to treat it as an equal to for a moment, because we know the inequality really only impacts the shading. So if I put in 0, 0 squared is 0, so I would have y squared equals 9. So what's y? 3, or, so that's really 2 points. Let's do when y is 0. If I put in 0 for y, then I would have x squared equals 9. So x could be, so I have 4 points, 0, 3, 0, -3, 3, 0, -3, 0. Can you tell what this is? Yeah. Solid or dashed? Okay, so if I try my test point, I would have 0 is greater than 9. Is that true? So 0, 0 does not work. So we're shading anything outside the circle. Okay, then. Did you eat lunch? This one, if we solve for y, we have y is less than or equal to negative x plus 3. So that's just a line. Y-intercept 3, slope is negative 1. Solid or dashed? Okay. And then you figure out where to shade. So less than would tell me below, or if you do your test point, you get 0 is less than or equal to 3, which is true. So my overlap is everything under this line and outside my circle. So okay. Let's do one more nonlinear one. What's y equals x squared minus 4? The parabola, the minus 4 would move it. Since it's not inside the square, it's actually going down 4. So 0, 0 would become 0, negative 4. If you put in a 1, get negative 3. If you put in a 2, get 0. So with the negatives. No equal to, so it's a dash. See where we shade. We would have 0 is greater than negative 4. Is that true? So 0, 0 does work, so we are shading inside this parabola. This one we have a line. Y-intercept negative 2, slope of 1. Solid. Which way would it shade? Or because of the less than, where you could do your test point. So our overlap is everything under this line and inside the parabola. Those okay? Let's do at least one more. Have 2 if we need them, but you're not limited to just 2 equations. So let's look at one with multiple. right. Start with the easy ones. Y is greater than negative x plus 2. We can graph that pretty easily. Equal to half. Which side would you shade?
Top side.
Mm-hmm. Put in 0, 0. And you'd have 0 is greater than 2, which is not true, so you can't shade the 0, 0 side. Bottom one, your y is less than negative 2x plus 10. So 10, slope of negative 2. Okay, and where are we shading that one? Bottom part of that one. So currently our overlap is between those two. Now let's talk about this top. Negative 4 is less than x is less than 0. What would I do with that?
Is there like an open circle and then like a line?
If we were doing like a number line, yes. But think about here. If I said x equals 4 or x equals negative 4, how would you graph that?
I don't know. Or a vertical line.
X equals is a vertical line. So we have a vertical line at negative 4. We have a vertical line at 0, and it's saying x is between them. So we have two vertical lines and everything between them. So we start at negative 4 dash because there's no equal to. Right, and then it's 0. And shape them to. So our overlap. And we can have more. Here, essentially, we had 4 equations. The x equals negative 4, x equals 0, and then the other 2. Do we need more practice with these? You got it? Okay. So I have book problems for the first time in a long time.